Good afternoon, I'm Mr. Precella, and we're going to look at solving absolute value equations today. And as I've told you repeatedly, this assignment will be less painful than the assignment that you had over the weekend, solving rational and radical equations. First of all, let's start off with a definition of absolute value. I know y'all have all seen absolute value somewhere or another. We use big vertical bars to denote the absolute value, and we'll say the absolute value of the number n is the distance from 0 to the number n on a number line. When we think of a real number line, we think of 0 right there in the middle, and to the right our numbers are positive, and to the left they're negative. So if we wanted something like the absolute value of, the absolute value of -2. How far is -2 from 0 on a number line? Just count the number of units. 1, 2. The absolute value of -2 is just 2. And likewise, if we looked at the absolute value of +2, how many units is +2 from 0 on a number line? It's still just 2 units. When we look at a number line, the numbers to the left of 0 have a negative sign appearing in front of them, and the numbers to the right of 0 are thought of as positive. But realize here we're measuring a distance. It wouldn't make sense for me to say the distance from here to Houston is -210 miles. Distance is not a negative value. Those negatives there are just indicating that that's to the left of 0. So, I have another one. What about the absolute value of 0? How far is 0 from 0 on a number line? It should be obvious. 0 units. How far do you have to move at 0 to get to 0? 0 units. And realize that for any positive value, there are going to be 2 numbers that have it as the absolute value. For example, if I wanted the absolute value of 7, we would say that that is 7. And once again, the absolute value of -7 would still be 7. Okay, so you got the hang of the idea whether the number inside the absolute value bars is positive or negative. The thing you get there is going to be positive. So the absolute value of positive or negative n is going to give you a positive result. Oh, I have a good one. Still playing around with this notion of absolute value. Suppose we had the absolute value of something is equal to -7. What number can I put inside those absolute value bars so that I get an absolute value of -7? Don't say 7 or -7. If you put 7 or -7 inside there, their absolute value is going to be a +7, not a -7. So, nothing. The absolute value of nothing is going to equal -7. No matter what you put in there, the smallest result you can get is 0. Anything else inside there, the absolute value will turn out to be positive. Let's summarize what we've seen so far, okay? a summary. I think I'll use Roman numerals. I think I'm going to use Roman numerals. Here's case 1. Case 1. Okay. The absolute value there. Here's case 1. Let's see. The absolute value of x equals a positive number n means the thing inside there has to be positive n or negative n. That's what we saw right here, just looking at this situation with 7. You can have the negative 7 having an absolute value of positive 7, or positive 7 having an absolute value of positive 7. If the number on the right side of the absolute value bars is a positive number, the thing inside there has 2 possible values. Case number 2. If you have an absolute value equaling 0, what's the only thing you can take the absolute value of and get 0? 0. That means that x is equal to 0. I don't know that that even pops up in this assignment. The third one, case number 3. If you have an absolute value by itself on one side and it equals a negative number on the other side. You have an absolute value by itself on one side, a negative number on the other side. What do we know about this situation? Is that going to happen? No, that has no solution. Because no matter what you put inside that absolute value bar, once you take the absolute value of that number, you're not going to get a negative result. So if you have an absolute value by itself on one side and a positive number on the other, you have 2 situations. If you have an absolute value on one side equaling 0 on the other, then that just means the stuff inside the absolute value bars has to be 0. And finally, if you have an absolute value by itself on one side equals a negative number on the other, then that equation has no solution. But notice the way I was saying something I wasn't writing down. I was saying if you have an absolute value by itself on one side. So make a note as you're going through these equations. This is going to be an important, okay, rule. Always, always, always isolate the absolute value before deciding which of the 3 cases you have. You must always isolate the absolute value on one side of the equation always isolate the absolute value on one side of the equation before solving. That should be the first thing you do if you notice your absolute value is not isolated on one side. Now the stuff inside the absolute value, it may not just be a variable x. It may be something other than x. For this first example that I'm going to just make up, okay, there's an example. I think for this first example I will just have an x inside the absolute value bars. The absolute value of x minus 8 is equal to negative 3. Some people look at this and see, oh, there's a negative on the other side, which means no solution. That's not what I said. Remember, what I said was, if the absolute value is isolated by itself on one side, and you have a negative on the other, then there's no solution. But that's not what we have here. With our little rule, always, always, always isolate the absolute value on one side of the equation before solving. We need to get this absolute value by itself. What can we do to get rid of that minus 8 that's stuck there with that absolute value? Add 8. Okay, good. Oh, yeah. So plus 8 and plus 8. I don't think we're going to have that no solution situation now. We have the absolute value of x is equal to negative 3 plus 8 is. I agree. Now we have that first case, and that first case is by far the most common situation. An absolute value on one side, a positive number on the other side. Well, what's the only thing you can take an absolute value of to get a positive 5? There are two numbers. Negative 5 and positive 5. So you could write it out like that. Or you could even write out x equals plus minus 5 if the plus minus sign is there in the on the keyboard, but if the on the toolbar of my math lab. But if it isn't, you're going to have to write negative 5 or type in negative 5 and positive 5. Any questions there? Let's look at some examples from the homework. Oh, we're starting off with an easy one. This is number 1. Let me write it down, then I'll switch over. The absolute value of x is equal to 17. Oh, no, wrong one. Well, this one is about as painless as it gets. What's the solution to this equation? What can you take the absolute value of and get a positive 17? Okay, so positive 17 or negative 17. And I like to box in that what's called an obvious equation, where it's x equals a number. Kind of reminded me of a situation where a student was trying to type in x equals for the solution, so I'm just boxing in those numbers. Those are the solutions, and that's what we'll have to type in. So the solution set is, hey, look at that. Look at that. When I click down there, right there in the box, I see the plus minus hotkey. Why don't we use that? I'm feeling lazy today. Plus minus 17. Any questions? Even the messy ones here are going to be a lot less painless than what we were doing on Wednesday. Oh, here's number 2. Let me write it down. Absolute value of x is equal to a negative 20. There. Well, the absolute value is already isolated on one side, and what sort of number do we have on the other side? A negative. What do we conclude in this again? There's no solution. This is a case number 3 situation. Absolute value by itself on one side, a negative number on the other side. So there's no solution. I think they're going to say that the solution set is empty. So let's see. I think they're looking for empty set here. Let's see. Let's switch over and see what the options are. Does it say there's no solution, or does it say that The solution set is the empty set. Any questions? Okay. Here's something a little more interesting. As I said, in many cases, you won't just have a letter appearing inside the absolute value bar. So we had number 3. We have the absolute value of x minus 3 is equal to 17. Hey, before we go on, I want you to look back at that first example I made up. Notice up here, this first example, that minus 8 was not inside those absolute value bars. So we had to get the absolute value bars by themselves. Here, the minus 3, that's part of the absolute value. I claim the absolute value, well, the equation's already in the desired form. We have a single absolute value on one side. We have a positive number on the other side. Notice the difference. You move those terms over when they're not inside the absolute value bars. But here, that minus 3 is inside those absolute value bars, so don't just start adding 3. What you can do is say, okay, this stuff here, in order to have an absolute value of 17, this stuff here has to be 17, or what's the other one? Negative 17. So you set x minus 3 to positive 17, set x minus 3 to negative 17. Solving x minus 3 equals positive 17, what do we need to do? Add 3, I agree. So that gives us x equals a positive 20. There's my first solution. And notice, when the thing inside the absolute value bar is anything other than just an x, you're not going to get the same number, but just opposite signs as your final answer. The second solution isn't going to be negative 20. Adding 3 here, what are we about to get? Negative 14, I agree. To give us x equals, I think I already said it, negative 14. So we have a positive 20 and a negative 14 as our two solutions. Notice it's not just plus minus the same number. Any questions there? So we have a positive 20 and a negative 14. Positive 20 and negative 14. Oh, this one looks good. Let me write down the problem. This is number 4. Oh, why did I do that? Is this equation in the form that we need, or are we going to have to move terms first? Do we have the absolute value isolated on one side? Yes. And what sort of number do we have on the right? A positive. That means this step inside here will have to either be, I'll get us started, 8 or negative 8. I agree. So we set 4x minus 5 equal to positive 8. And 4x minus 5 equals negative 8. Let's see, how am I going to solve this one? Let's start with this one. Let's talk me through. What will I do first? Yeah, add the 5. So we have, wow. Oh, the big mosquito. Oh, did it hurt? But lean back. I don't see any blood, so I think I stopped it. Oh, okay. So let me see. Okay, y'all talk me through. I'm distracted at this point. What am I going to do? Y'all said add 5, so is that going to be 13 right here? And then divide by 4. So 13 over 4 is my first answer. If I plug that in for x, that would give me a positive 8 inside here. And let's see, what about this one over here? Go through the same steps. I'll add 5. So negative 8 plus 5, is that a negative 3? And then divide by 4. Oh, so we're going to have 2 fractions as our answer. If we plug a negative 3 over 4 in for x, can y'all do that? Okay, imagine putting a negative 3 over 4. The 4's would cross cancel. We'd have negative 3 minus 5. That would give us a negative 8 inside. So sometimes there's stuff we do that I'll give you the quadratic formula and you got to trust me that it works. Here you should be able to logic your way through these. Why am I saying set equal to 8 and negative 8? Well, that's the only numbers that could be inside those bars to have absolute value equal to 8. So let me see. I'll patch it there, and let's see. 13 over 4. Right arrow, or else just move to get out of the fraction, and then a comma. What's that other one? A negative 3 over 4. And I will check it. Any questions on that? We're flying right through these. Okay. Okay. Always, always, always isolate those absolute value bars first. Okay? Always, always, always isolate the absolute values on one side of the equation before solving. I'm going to put a little cube right here on Tim's rule because it should say always, always, always. So that little cube does that for us. Let me write down number 5. What was it? Let me see. Number 5. Absolute value of 9x, then a minus 9 equals 72. Hopefully y'all can tell my absolute value bars from my 1s. There's not a 19 in this problem. Okay? Just like up here, it's not 14x minus 51. Okay? That's why I'm trying to make those absolute value bars distinct. There's only one first step. What's that correct first? There's only one correct first step. What's the first step I'm talking about? Move that 9 over. If you go equal 72 and equal negative 72, you're going to get one right answer and one wrong answer. So if you find yourself, oh, I'm only getting one answer right, then what you're doing is you're not isolating the absolute value bars first. Let me see. I'll start off by adding 9 to both sides. So we have the absolute value of 9x equals, is that going to be 81? 72 plus 9? And now, are we ready to go equal positive, equal negative? Yes? So 9x equals positive 81, or 9x equals negative 81. Divide both sides by 9. Would that isolate the x? Goal is to get x equals a number. So we have x equals, is our first answer positive 9, and what's that second answer going to be? Negative 9? Positive 9 and negative 9. I guess you could type that in with just a plus minus. If it gives you the plus minus hot button, which it does. There and there. Oh, you could have done 9 comma negative 9. I'll take over. Okay. Okay, you reminded them. Tony would have reminded y'all here, switch over. At this point here, always, always, always isolate the absolute value before you do anything else. So looking at number 6. Oh, there's no square roots in this assignment, is there? That's pretty nice. Oh, this is a good problem. I think the absolute value bars are already isolated on this one. But I think there's something else that the students don't like. What is it? Is there something about this problem that makes it less attractive? The fraction? Yeah, okay. Okay. Switch over. There. Oh, lift it up. There. But notice, we already have the absolute values isolated on one side. We have a positive number on the other side. So that means this stuff here, the only way an absolute value can equal 7 is for the stuff inside those bars to be what numbers? I'll get us started. 7 or negative 7. I agree. So we have 2x minus 5 all over 5 equals a positive 7, or 2x minus 5 over 5 equals a negative 7. And maybe the quickest way to solve this equation is to treat it as if it's a proportion. Have one fraction equals another fraction. Well, that's 7. That's like a 7 over what? 1. So just cross multiply. 2x minus 5 times 1 is equal to 5 times 7. 2x minus 5 times 1, though, that's easy. That's going to give us what? Just 2x minus 5. What are we going to have on the right-hand side? 35. I agree. 7 times 5 is 35. We cross-multiplied. 2x minus 5 times 1 gave us 2x minus 5. 7 times 5 gave us 35. And then what are we going to do to solve this equation? There's really only one correct next step. Okay, by doing what? Adding 5, I agree. To give us 2x equals. And then divide by 2 to give us x equals. So there's my first solution that I found is 20. Now the second solution, I think we'll do it the same way. I'm going to put that negative 7 over what? 1. Now be careful. Don't put the negative in both places. If you put a negative 1 down here, negative 7 divided by negative 1, is that a negative 7? No, so that negative is up there with the 7, but down here you're multiplying by a positive 1. So cross multiplying once again, we're going to get 2x minus 1 times positive 1 equals, 2x minus 5 times positive 1 equals 2x minus 5, I agree. But on the right-hand side, what are we going to have? 5 times negative 7, I agree with the negative 35. And then add the 5. That's 2x equals here. Okay, negative 35 plus 5. I agree with negative 30. And then, okay, so we'll divide again. Dividing by 2, that's going to give us x equals negative 15. Negative 30 divided by 2 gives us a negative 15. So we have two solutions, 20 and negative 15. Comma negative 15. Any questions? Just keeps getting easier and easier.
Well, number 7 is the last one, so the hardest one. The last one's always the hardest, isn't it?
Let's see. It's not bad. Let me write it down.
Don't make it look like 1m plus 51.
I know, that's why I use different colors. Every time I do one of these, when I write my absolute value bars, I try to use a different color to distinguish those absolute value bars. That equals 18. Okay, let's switch over.
There's only one correct first step. Only one thing you can do that'd be correct right off. And what is it? Subtract the 2.
So
You've got to isolate those absolute value bars.
So minus 2, minus 2. I tell you, that's one thing I've noticed, Tony. I'm a big fan of horizontal lines throughout the work, okay? But
I'm not.
You don't do that. Maybe I'll convert you. 18 minus 2, what have we got over here? 16. And now, this is in the desired form. We have an absolute value on one side equaling a positive number on the other. That means that the stuff inside those absolute value bars, m plus 5, m like money, has to equal, I couldn't hear you, positive 16? Okay. Well, your hearing's better than mine. Or negative 16. Just between you and me, Tony, I probably, if I looked, I'd probably find that hearing loss is one of those bizarre side effects of those cancer shots also. So maybe I'll start using that as an excuse for my bad hearing. In reality, it's just loud music at a young age. Okay, what are we going to do here? Oh, wait a minute. I was getting excited, but we're not through yet. Don't be thinking this is the end of class. There's something else we need to discuss. And that gives me m equals 11. Okay, there's my first solution. What are we going to do here? Subtract again, okay. And that's going to give me m equals negative 21, I agree.
Looking at this with the different colored horizontal lines, I'm sort of liking the look. It sort of adds a splash of color to the page.
But then again, Tony, you're not trying to plan a banquet dinner, putting a lot of different colors on the plate to make it more attractive. So maybe, yeah. I remember the first time I had to plan a banquet. 11 comma negative 21. We went with the chicken fried steak, the mashed potatoes, and I think corn. It was the dullest looking plate. You could have people sitting down. Oh, and that's when I learned you got to always have different color items if you're planning a menu for a banquet.
Now, I want to sort of change up. Suppose this number 7, there's 2 examples I want to do. Let me see. How about this one?
Okay, I'm going to switch you over.
Suppose number 7 had looked like this. X plus 5. Let's see. Plus 8 equals 2. Let's see. This one. What's the first? Oh gosh, you talk it first. Yeah.
Okay, what's the first thing we're going to do?
Oh, I didn't make it in a different color.
I know. What's the first thing we'll do? There's only one correct first step. I think it's minus the 8, okay? We're getting those absolute values by itself, okay? And so that's going to give us the absolute value of x plus 5 is equal to, here, negative 6. Oh, I like that, because it brings up the fact that, okay, you have a positive number here on the right-hand side, but that means nothing unless the absolute value is isolated. Once the absolute value was isolated, what have we got on the right-hand side? So what do we conclude? No solution. Okay. Negative, so no solution.
You can't decide no solution unless you have those absolute value bars isolated. That's what I wanted to indicate with this example. And now to write the second one.
I think I know where you're going with this. I'll say x plus the absolute value of x plus 5 minus 8 is equal to negative 2.
You cannot immediately say no solution because there's a negative on the right-hand side. You've got to isolate those absolute value bars first.
So, isolating the absolute value bars. Oh, well, first of all, tell me what we're going to do. Add the 8.
And y'all see where this is going? Is this one going to be a no solution?
No, it isn't, because we're going to have the absolute value of x plus 5 on one side. What are we going to have on the other side? A positive 6. So now that's a positive number, so we're going to have 2 solutions. The thing inside there, x plus 5, must equal, what are the 2 cases? Positive 6 or negative 6. Solving this first equation for x by subtracting 5, we're going to get x equals.
They could do that in elementary school. Blank plus 5 equals 6 or 1.
Oh, okay. I just like them to answer that says they're awake. Subtracting 5 here, we get x equals negative 11. That's right. So we have positive 1 and negative 11. Oh, well, we don't type it in. We made this problem up.
But you cannot decide between no solution and equal positive, equal negative, unless you have those absolute value bars isolated.
Always, always, always isolate the absolute value bars first.
At first glance, this one right here, the first one, has pluses and positive. You don't even see it. There's no minus sign anywhere in the original problem. Okay? Whereas here, there's 2 minuses, but it's still not a no solution. You've got to get the absolute value bars isolated first. Any questions over that? Okay.
Yes.
So on the one that did in the family negative,
Yep.
isolated when it's a
no matter what you plug in here for x, no matter what you plug in, when you take the absolute, looking at it, this isolated form, no matter what you plug in for x, when you take the absolute value, what sort of a number are you going to get? A positive number. You'll never get a negative number. You'll never get a negative 6.
So that rule about
If there's a negative number, let's see, my third case right here.
okay, that rule is only true if the absolute value bars are isolated. Okay, looking at all of these cases, the absolute value bars have to be by themselves. Are we answering the question?
Yeah, so what I'm thinking is, so if you were to work it out, all the other
If you try to go equals 6 equals negative 6,
exactly, but if you plug that in,
it would not work.
That is correct.
Because if you went x plus 5 equals 6, that would be a 1. You're not the right answer. Okay?
Okay. Okay, there's something else I want to look at.
Wait, any other questions over that?
Yep. Okay, interval notation.
We're going to review something that you'll need to know the next time on Wednesday. And I'm saying we're reviewing it. You may have seen it in a previous algebra class. If you haven't, well, that's fine also.
I'll tell you right now, I did not see interval notation until my first semester of my first calculus course.
Yeah.
And then I was like, oh, okay.
Yeah, it's
okay.
nothing hard.
But
okay.
still, they used to teach it at a much later point, but now it seems it's taught early on. So you may or may not have seen it. Interval notation is a means of expressing intervals on a real number line. So I'm going to draw a number line, and I'm going to put some numbers on that number line.
So this is a number line, and he's just going to draw some plot some numbers on the number line. Remember, the negative numbers are to the left of 0, positive numbers are to the right.
Okay. Okay, I'm going to start. I'm going to have a closed circle at negative 4. I'll have an open circle at negative 2, and I'm shading between negative 4 and negative 2. We'll discuss what those open and closed circles mean in a moment.
Why not just say it right now?
Oh, the closed circle means that that endpoint is included. Negative 4 is being included in that endpoint. The open circle means that negative 2 is not included. The numbers to the immediate left of negative 2, like negative 2.0000001 are included, but negative 2 itself are not.
So the blue interval is all the numbers between negative 4 and negative 2, including negative 4, not including negative 2. Now, make a red interval now.
Oh, a red interval. Okay. How about I will go. Close. And okay.
Now here, when we're saying numbers, we mean the real definition of numbers, including the decimals and fractions and stuff. Like the red interval, it's all numbers between 0 and 2, including 0, including 2. On Thursday, the Tuesday, Thursdays are ahead of us because of the Labor Day holiday. On Thursday, a student said, so you're talking about 0, 1, and 2. And I was like, and all the decimals, like 1.3, 1.285. Go ahead, Tim.
Real numbers are dense. Between any two real numbers, there are infinitely many more real numbers. So between 0 and 2, there are infinitely many numbers. You could say, well, there's 1, there's 1.01, 1.001, 1.0001. You could just keep on going on forever, sticking a 0 in before that last 1. That should convince you there are infinitely many numbers there in that interval. And there's one more interval I want to look at. I'm going to include 4, and then it's going to just keep going and going forever to the right.
So the black interval are numbers bigger than 4, including 4. Okay, so he shaded 3 different regions.
With interval notation, we're going to use brackets, either a left bracket or a right bracket, depending on where the closed circle is. They'll be used for closed circles. I'll say closed dots. If your number line has a closed dot at the end point, you'll put in a bracket. You'll use parentheses if you have open dots. You will also use, by the way, notice this interval here, it never stops. It just keeps going and going and going forever to the right. This interval does not have a stopping point on the right. So to indicate that, we're going to use a positive infinity.
In fact, you can label this one over here negative infinity, not that you need it.
Well, in a minute we'll do one where we'll be looking at this interval to the left, and so that side there, left, that keeps going and going, we would think of that as negative infinity. So, on Wednesday, we're going to be doing something called the cut point method. We'll go through this long process, and we're going to build a number line. It's not that long, you're right. It's not as bad as square root equations, okay? So, I'll tell you that much right now. But we'll build a number line. We're going to get these numbers that we'll call cut points labeled. There'll be a process to determine what cut points you label on the number line.
There'll be a little recipe that you follow. Step 1, 2, 3, 4, 5. By the end, you will have amazed yourself and have the solution.
Then you'll go through a process and decide, this interval isn't going to be shaded. This one will be shaded. This one won't be. What I'll do is, as I go through the process of the cut point method, I'll be crossing out intervals, okay? Those aren't the ones shaded. Here are the ones that are shaded. So, the last step of the cut point method, you've gone through this process to build a big old number line. You have to express the shaded intervals using interval notation. So to say this interval here, the left-hand endpoint is a -4. It has a closed circle, so we'll put a bracket.
I'm going to write it in blue.
A bracket, -4, comma, you've got to put the comma. Then the right-hand endpoint is a -2. That's an open circle, so you'll put a parenthesis. The brackets and parentheses you'll just type from your keyboard, okay, when you're typing in the answer. So there's the first interval, or that is a U. They'll have that symbol on your toolbar. That's a set union. I just read it as or, the numbers in this interval, or now the red interval. Let me ask you something about the red interval. What will I start and stop with? Will I have brackets or parentheses? Brackets, because both of those dots are closed in. So I'll say bracket. The left-hand endpoint is 0, comma. The right-hand endpoint is a 2, bracket. Union.
So basically the unions are just saying that it's all on the same number line.
It's this interval or this interval, or there's another interval.
If you weren't putting the union, then it would be like you had 3 different number lines.
3 different intervals on 3 different number lines. Okay.
This is all on one number line. 3 intervals on one number line.
Looking at this last shaded interval, the left-hand cut point is a 4. What are we going to have at that 4? Bracket or parenthesis? Bracket, because that's closed in. So 4, comma. It never ends, so to indicate that it keeps going forever in the positive direction, we put a positive infinity. We don't have to write the positive, because if you don't see a negative, you assume it's positive.
Now,
you always use a parenthesis with, I didn't write that down there, okay?
But I was going to have them think their way through it.
Or
parentheses
positive or
mean not included. Brackets mean you're including the number. And so,
This is infinity isn't a number that you're going to get to and include. It's just representing an abstract concept.
it's
So-
representing this arrow. It wouldn't make sense to say including the arrow. So what are we trying to say? You put right here?
A parenthesis.
Always put parentheses beside infinity symbols.
Or negative infinity.
Well,
Let's do one more.
okay.
Any questions there? Bracketed closed circles, parentheses at open circles, or at infinities. So, we'll do one more.
Oh, wait, so what is this interval notation for? It's shorthand notation. If someone asks, what are the shaded intervals? What numbers are shaded? This little stuff right here, I'm about to say it out in words. All numbers between -4 and -2, including -4, not including -2, as well as all numbers between 0 and 2, including both 0 and 2, and all numbers bigger than 4, including 4, not including infinity. This is just shorthand notation for all of that. That's what the purpose of interval notation is. Oddly enough, you go back and find some math books 40 years ago, there wasn't all this interval notation on it.
It really is.
30 years ago also.
Okay, so I'll say -3 and 1 and 4 and 7. Okay, so that's 7. I'm going to change this last number to, no, I guess I'll just leave it as 7. You're right.
The numbers don't really matter as long as they're in numerical order.
Well, they do when you get to the what we're doing on Wednesday, but that's a 7 there, so don't let that there. The 7. And open it. Stand and open. So here for this example, I'm just alternating closed, open, and I'll shade here. I won't shade this one. I'll shade here. Won't shade that one, and I'll shade. Goodness, there's my purple. There.
So by the end of the fourth step of the cut point method, you'll have those cut points labeled on the number line. You have open and closed circles, and you'll have regions shaded. Now let's do step 5 of the cut point method, which you haven't seen yet. Well, I think I'll print it out and bring it.
Yeah,
Okay,
I think
to them.
so.
Write it out in interval notation.
I'm going to let y'all call it out to me. Pretend you're typing for this first interval, the blue interval. What would you type first?
I'd label those arrows with infinity.
Infinity or I'll give you a hint. There. So what am I going to put first? Parentheses, and then always precede a negative infinity with the parenthesis, comma, and realize you've got to put that comma. What's the right-hand end point? What are we going to have after the -3? Parenthesis or bracket? Bracket. Okay, there. Or
union.
Union. I'll read that union as or. Okay. The second interval, the red interval, call it out as if you're typing it. Parenthesis or bracket? Parentheses, because you have an open circle at the 1, comma, 4, bracket, union. Okay. This last interval, that's 7, 10, it starts at 7, it goes to the right. So call it out. What would you type? Parentheses, 7, comma, infinity and what goes after the infinity, and other parentheses.
Just don't forget that. And if you do, it's not anything hard. And step 5 of the cut point method, when I give you all the little recipe that we're going to be following, it will...
it'll have a little reminder. It'll say use brackets for closed dots, use parentheses for open dots, always use parentheses with infinity and negative infinity.
Any questions? I wonder, do y'all remember doing this open and closed circle stuff and shading sometime along the way? Or is this new to you? It's all new to you? Okay.
Okay, just remember, really the only time you use those rectangular brackets are at closed dots. That's the only time you use rectangular brackets, or with closed dots.
Open and infinities, always parentheses. Any questions? Well,
today y'all get to go early and enjoy the fact that you have a short homework assignment. Some of y'all are moving right on along. I don't know if those people are here right now or if they're, just watching the videos and not even coming to class. That's perfectly fine. The course is set up like that. But some of y'all are moving quite, and if you get to that, say the quiz, one person I know has already just skipped over the first quiz and it's just kept on going. You can take the first quiz. You don't have to wait until the day that it's due. Preferably, you take the quizzes and tests before the due date, okay? But,
So I'm going to go ahead and stop the recording right now.